Hello, everybody. My name is Mirko Novakovic. I am co-founder and CEO of Dash Zero, and welcome to Code Red. Code, because we are talking about code, and red stands for requests, errors, and duration, the core metrics of observability. On this podcast, you will hear from leaders around our industry about what they are building, what's next in observability, and what you can do today to avoid your next outage. Today, my guest is William Morgan. William is the CEO of Buoyant and the creator of Linkerd, the first service mesh in Kubernetes. He previously worked as an infrastructure engineer at Twitter during its transition from monolith to microservice, and he has held engineering roles at Microsoft, PowerSet, and Adaptive, with early research work at Mitra. Excited to have you here, William.
Thank you. Excited to be here.
And I always start with my first question, and that's about your biggest Code Red moment in your career.
So there's two memorable incidents that I was involved in at Twitter. One of them kind of stressful and hectic, and the other was funny. When I was there, this is a long time ago. This is 2010, 2011. Twitter at that point didn't have a photos handling service, like adding photos to tweets you couldn't do. People had these third-party sites like YFrog, and so Twitter was like, well, we should add this capability ourselves. So I was in charge of the engineering efforts on the back end to handle the photos service. And so we launched it to great fanfare, and we provisioned it, did all the capacity planning, rolled it out slowly. Everything was great. Okay, all's well. And then, it's Christmas holidays. So, I took a couple days off, and then it turns out that on Christmas Day, a lot of what people wanted to do was take pictures of their presents. And so the photo service went down hard on Christmas Day because of capacity issues. And I pretty much spent the whole of Christmas away from my family, locked in a room on Campfire, which is like the precursor to Slack, trying to get this poor thing back alive. So that was a sad one. And the funny one was, maybe a year or two later, we had a report that suddenly all images across all tweets were all showing the same image. Like every tweet that had any image in it, it was the same image. It was a picture of this guy's elbow. And so it was, if you tweeted a tweet with any picture, it would turn out to be this guy's elbow. President Obama at the time was tweeting stuff, and it would be some White House announcement or something, and it'd be a picture of an elbow. And so, that could have been really bad if it had a different picture. It turns out that was a CDN misconfiguration. So that was just they were dropping the query parameters or something. There was something that actually selected the image, that they were just all, everything was going to the same image. So that could have been really awkward. But luckily that was, I wasn't on the CDN side of things, so it's not my fault. But I was definitely pulled into it because the initial assumption, of course, was oh, something's terribly wrong in the photos service.
Interesting one is most of the stories here either begin with Christmas or New Year's Eve.
Yeah.
So it looks like these days are always special days.
Yeah.
And the other thing is that also most of the problems turn out to be some sort of networking issues, right? Like CDN or DNS or which is good.
Was that a sad reflection on the state of modern society? I feel like people should be staying off of their computers on Christmas and New Year. Well, maybe New Year's you can take photos, but Christmas you got to stay with your family. Well, no, turns out people use their phones a lot on Christmas.
Absolutely. Tell me a little bit about, Linkerd, right? Is that the correct?
Yeah, that's right.
How did you come up with it? What is a service mesh? Let's start with that.
Yeah.
And how did you come up with Linkerd at LinkedIn? And why did you build it?
Yeah, so a service mesh is an infrastructure layer that kind of sits in between where your network is and where your application is. And basically what we do is we provide the platform, especially if you're on Kubernetes. Almost everything we're doing is Kubernetes focused, with the ability to do things like retries, timeouts, circuit breaking, cross-cluster communication, neutral TLS on by default, authorization policy and instrumentation, all at the level of HTTP and gRPC. So traditional networking is concerned with like, how do I get TCP packets from here to there? How many packets are flowing? What's the source IP address? What's the end IP address? The service mesh kind of takes that up a level of abstraction and gives you control and instrumentation at the level of, I'm service A and I'm talking to service B, and how many HTTP requests are flowing. And when I load balance, I'm load balancing like HTTP requests, not packets or connections. So the origin also was at Twitter. So one of the things that was happening there was, when I started, Twitter was a monolithic Ruby on Rails application, and by the time I left, we had moved off of that Ruby on Rails app into a big distributed system, what we would now call orchestrated microservice environment, although, kind of like a precursor in some ways to what we're doing today with containers and Kubernetes. So we didn't really have containers, but it was on the JVM. So we had like, memory boundaries from the JVM and packaging from the JVM, and we use C groups for isolation. So it's kind of like containers. And then we had Mesos, which was, a grad student project at the time, but Twitter kind of productionized it and became a huge orchestration framework. And we split all the code that used to be in that, Ruby on Rails monolith into microservices. And as part of that, we ran into all sorts of distributed systems problems. So like A wants to talk to B, well, it turns out when that's a function call, right? When it's like function A calling function B, even in Ruby, right, it's really fast and it doesn't fail, but when you turn that into a network call and you have 100 instances of service A talking to 1,000 instances of service B over the network, and some of them are failing and some of them are on the JVM, which is running the garbage collector. And so they're non-responsive for 500 milliseconds. You have all sorts of problems. So one of the things that Twitter had to kind of engineer its way out of was, how do I make that communication really reliable and secure? And so they created a bunch of open source libraries. And when we first started Linkerd, the idea was, let's literally take those open source libraries and let's turn them into something that the rest of the world is going to be able to use. Now, those libraries were like Scala libraries. So it was, they were useful if you wanted to do like functional programming on top of like RPC calls or something. So, our genius idea in the beginning was, well, let's just turn it into a proxy, right? And then the proxy can now do the operational stuff for you. And it doesn't matter what language you're written in. And then pretty soon Docker containers, were around, and Kubernetes was around, and we had ways of inserting those proxies, into the platform without the developers having to know anything about that. And that's kind of how we ended up with Linkerd, where we say, hey, developers don't actually need to know anything about this. This is a tool for the platform owners. And if you are a platform owner and you want to start instrumenting, all of your applications with HTTP metrics and gRPC metrics, if you want to start adding control and reliability and security, you can actually do that without having to get into the developer's hair. And it doesn't matter what they're doing, doesn't matter what language they're running, writing their code in. As long as they're speaking HTTP or gRPC, we can do something. We can give you these guarantees that Kubernetes itself doesn't actually give you. So there you go. Long answer to a short question.
Yeah, I remember when I saw it the first time, and I was still building in Stana, we were not sure internally if that's actually a competitor or not, right? Because one thing you can do with the service meshes is you can actually collect the traces and statistics, etc., right? Because you have all the calls, you basically understand the flow through all those microservices. You can also create a trace. And so our question was, okay, is that actually an observability competitor or not, right? Because you don't need agents anymore, right? Because actually the mesh, or I don't know if you also work with sidecars and these things, and these sidecars can collect the data and send it and create statistics, etc.
Yeah, exactly. Now, the kind of the boundary that we did with Linkerd is, we will instrument everything and we will emit those metrics, but we don't actually do any collection or aggregation or analysis or whatever. So we'll observe and instrument everything because we're right there, right? Every HTTP call, every gRPC call, it's passing through the proxy. We can give you all sorts of wonderful information that you're not going to get from the network hardware. But what you do with that information, we kind of leave that up to you. And that's like the surface area of the service mesh.
Yeah, absolutely. No, and that's why we also cooperate with you and others, right? To collect the data and make an out of the box good experience. But I read that one of the things you said is about telemetry and collecting those telemetry, that most of telemetry is wasted, right? And that people collect a lot of data, but they don't actually improve their decisions based on it. And I totally agree with that, right? I always say 95% of all telemetry data collected by observability tools is garbage, right? At the end of the day. So how do you see that problem evolving also with microservice? I think it's getting worse, right? Not better.
I think that's right. And, to some extent, I don't have to solve that problem. Like, to some extent, I'm like, you know what? My job is to instrument everything that we can. You figure out the rest of the story. But obviously, a lot of what we do at Buoyant, which is the company behind Linkerd, is we help our customers adopt Linkerd and like make use of it and build these reliable platforms at scale. And they're doing incredible things with it. And obviously, as part of that, we have to help them come up with a story for and a strategy for how they're handling this data. So, and I'll say I'm not I'm a service mesh expert, but I'm not really an observability expert. So I kind of like I have my opinions, but take them with a grain of salt. In my mind, like you have to start with like what's the value of any of this data, and to me, the value of this data is to the degree to which it allows you to make some kind of actionable decision, right? And it's easy to collect data. That's the problem. Is it's easy to, well, there's everything. We've got all this stuff. Throw it in the bucket. We'll deal with it later. So that's kind of like your reflex, right? We don't want to lose anything. We better collect it all. But the value of that data is really only there if you can do something intelligent with it. And so there's kind of two sides to that. Obviously you have to collect it, but then you have to turn that into some kind of actionable insight. And yeah, the more data you have, kind of like the more extreme that delta is, because my experience has been, and again, I'm not the world's observability expert. My experience has been the vast majority of this data kind of just goes somewhere, sits around, and no one ever uses it for anything. And so you end up, wasting a lot of resources, money, disk space. Maybe I don't care about disk space, but everything has a cost. And if you're not doing anything with it, then like, what's the point?
Absolutely. And you were talking about scale and talked about scale. And I mean, Twitter and LinkedIn are probably two of the largest scale internet companies. And how would you categorize Service Mesh and Linkerd? Is that more something for kind of applications in a certain scale? Does it make sense for a small app? And we can also discuss this monolith versus microservice. When does it make sense? Is it like the next step? So I start with the monolith, then at some point I need to scale it up and do microservices, and then at some other point I need a service mesh to really work with it. So how do you see that? How does it fit into? And then I would come to my question on observability with that. But first, to understand, where do you see the fit for a service mesh, and when would you use it? At which scale?
First, I'll clarify. I didn't work at LinkedIn. I got friends who worked there, and like they did amazing things on the infrastructure side. Especially kind of the time I was at Twitter, there was a lot of cool infrastructure stuff happening at LinkedIn. But yeah, I went straight from right after Twitter. We started
Okay.
started creating Linkerd. My opinion on this has changed over the years. I think in the beginning I would have said, yeah, everyone needs a service mesh. Like, of course, put it in there. Why not? Like everyone needs observability. Everyone needs security. I think the reality is there's an operational cost to everything you're putting into your stack. And so you have to make a decision, and this isn't service mesh specific, but every time you're adding something into your environment, you need to make a decision. Like, is the cost that I'm paying here worth the value that I'm getting from it? And I think from kind of the operationally focused mindset, the cost that you're paying for introducing these systems into your environment they're kind of operational costs. They're like, well, someone has to own this thing, or some team has to own this thing. They have to be on call for it. They have to monitor it. They have to understand it. They have to know when it's time to upgrade. They have to like be on the hook for, when things don't go well and maybe this component is to blame. And so that cost is trivial. And also kind of the degree to which any particular component is in the critical path is a big component of that cost. So if you have something that, is off to the side, like maybe you have a load testing harness that like kind of sits off to the side. Okay, well, that's not such a big deal because, you can turn it off, right? Like nothing, the production still runs. Um, but with the service mesh, we're like a pacemaker. We're inside the beating heart of your platform, and we're at the intersection of the network and the application and the Kubernetes cluster. And if any of those things start going wrong, the service mesh will feel the pain. It's like we're the canary in the coal mine, but the canary is also doing the mining, right? So if your cluster starts running out of resources, the service mesh will start feeling that pain. Or if your network starts, having issues, the service mesh will start feeling that pain. So I would say the operational cost to a service mesh, we try and make it as small as possible. And I think Linkerd is dramatically simpler and lighter weight and easier to understand than any other service mesh. And I'm very proud of that. But the cost is not small. So this is all to say, I think you need to have kind of a substantial platform for Linkerd to really make sense. And I think that requirement is probably 100x for other service meshes because the level of complexity is higher. But even for Linkerd, which is as simple as we can make it, it's a pacemaker. And like you need to have, I would say you need to have a pretty serious application where you really care about reliability, really care about security. Often, for our customers, they're thinking about not massive, but at least multi-cluster deployments across different regions, and like, how do we connect these things? So in that world, and the service mesh is a no-brainer. Like, yes, well, I don't know how else you would even accomplish that stuff. If you have like a single cluster and a lightweight application and like, kind of everything is sitting at, 50% utilization, you probably don't need it, so, that's fine. I wouldn't want to push you to use something you don't need. So like anything, it's a trade-off, right? It's like a complex, messy engineering trade-off, but that's what we've learned having taken customers to production for, 10 years now with Linkerd all over the world, all sorts of crazy different applications from like e-commerce to like 911 call centers. Linkerd is powering all that stuff. And really there's a level of complexity at which like, you need this thing. And below that, you can kind of get away without it.
It makes sense. And how do you see observability play into that complexity? And if you let's look at something like a retry, right? Some service is not available, and you can then retry and try other services
Yeah.
and or instances or in a different cluster. I mean, you can trace all the calls, right? But would you then also analyze that pattern, that retry pattern, or do you think that's part of the observability layer?
Probably that's ultimately part of the observability layer. So, the constraints that we operate with on Linkerd is we can't make things worse. The way this works is every pod gets its own tiny proxy. We call it a micro proxy because it's, if you compare it to something like Envoy, which is large and complex, the Linkerd micro proxy, it's super lightweight, super small. It's written in Rust. It is like a tiny, we make it as small as possible because we have to put one in every pod, right? Because that's the sidecar model. It's actually the best. It's the best model because it gives you the clearest security boundary, clearest failure domains, clearest operational kind of like packaging. And so one of the things we do, to make that predictable and lightweight and performant is we reduce the amount of coordination that has to happen between proxies. So proxies largely exist independently. Obviously, there's a control plane, and they like talk to that control plane to get state information. But in terms of things like retry behavior, they're not sharing information, and they're not coordinating stuff. That would be an additional level that would be like a pretty significant level of complexity. So the proxy will do intelligent retry, right? And you'll be able to parameterize it, but any analysis of like what's the right retry behavior kind of at scale, that stuff has got to happen in some layer well above the proxy. The proxy's got to be making these lightning fast decisions. We've got to introduce like milliseconds of latency, not hundreds of milliseconds. Otherwise we slow everything down. And I will say, one of the things we learned at Twitter, pretty early on, and which has made its way into Linkerd since the very beginning, has been, for retries specifically, has been the danger of retry storms. This is like one of the classic distributed systems problems. How would you do retries? Well, I'm service A, I'm calling service B. I'm going to retry, up to 3 times. Okay, well, that might be aggressive. What if it's having a problem? Well, okay, I'll do exponential backoff. Okay, so I'll retry once and I'll wait a second, and then I'll retry, again. If it still doesn't work, then I'll wait 2 seconds, and then after that, I'll wait 4 seconds or something. Maybe I do that 5 times. That's how we started, and even that behavior, when you have a complex distributed system, and you have A calling B, calling C, calling D, a problem with D will cause C to start retrying, and then when C is retrying, it's returning failing responses. So then B will start retrying, and then A will start retrying, and pretty soon each of those, you had 3 responses here, now you had 9. So you had 3 retries of this layer. Now you had 9 over here. Now you had 27 over here. You have this horrific effect. So the way Linkerd has done retries, the way we parameterize it with budgets, and we make sure your worst case behavior is like, a 20% increase, not a 300% increase. Anyways, like, that's all logic that goes into Linkerd, right? Because we want Linkerd to give you these sane, kind of fail-safe defaults as much as we can out of the box. But the large scale analysis of like, wow, okay, what is this doing to overall performance? And, is this correlated with traffic that's like seasonal or like whatever? That stuff, that's out of Linkerd's domain. That someone smart needs to go analyze that data and come up with the decisions. We're just trying to retry the request as fast as possible without causing more problems.
Yeah, that's good. No, but that's exactly what I meant, right? Seeing these patterns would be an observability task, right?
Yeah, exactly.
The data. Yeah, that's interesting. And how do you see this changing right now with the introduction of MCP servers, LLMs, and are you also intercepting these calls?
Well, we are, to the extent that they're happening in the production cluster. So I would say, as an industry, the vast majority of MCP usage today is not touching the production cluster, but I think everyone senses in another year or 2 that's where we're going to be. So the vast majority of usage today is like, I'm a developer, I have my laptop, and I'm using, some fancy coding, AI-enabled coding tool, and I'm using MCP to like connect to these third-party services. It's not all the usage, but that's the majority of it, right? And so we're not going through production at all, except maybe on the far end where we're serving. Right. But the direction we're going is, well, we're going to actually have agentic workloads in the production cluster, and they're going to be doing stuff. They're going to be taking on these, this business logic. And in that world, well, now you have this new type of traffic in the cluster. And obviously that's interesting from the service mesh perspective, because it's happening over HTTP, but like all this stuff it doesn't look like normal HTTP, right? If you look at the MCP protocol, I mean, probably you look at the MCP protocol, your first reaction is like, who designed this? Because like they weren't really experienced at this sort of thing. But whatever, we're like, this is what we're going with. All right, well, let's figure out how to handle this. It's JSON RPC, which means you're passing these JSON blobs kind of back and forth. All the data is in the body. So like, if you just treat this as an HTTP call and you're just doing observability at that level, you're like, oh, I had a 4-second or a 40-second long HTTP call to /MCP, to the /MCP endpoint, and it returned to 200. Okay, sounds great. Whereas under the hood, this thing is, it's calling, who knows? It's deleting the database. Like, you have no idea. So you need to break the observability, into something more granular for MCP. So that's one thing that we're working on in Linkerd land, is just giving you the ability to emit metrics and to do security, kind of authorizations and things like that around, well, what tools are you allowed to call? And when you called them, what happened? Was it successful? How long did it take? All that stuff just has to be like parsed out. So, that stuff is kind of it's kind of straightforward. It's like annoying to handle this protocol, but it's, it's kind of straightforward. And then, there's more interesting stuff coming down the hood, coming down the pipe. But like, that's the first step.
And you do that on the network level, or where do you do that?
Well, so everything, the way Linkerd works is we have a proxy, a user space proxy that intercepts every call. That's or a micro proxy, right? And so that's a very natural place to put that parsing logic. And in fact, you almost have to do it there. Like you wouldn't do this in the kernel. You have to not only be able to parse all of HTTP2, which is a massive spec, but then you need to further parse JSON RPC and streaming protocols and blah blah blah. So yeah, we just do it right in the proxy, and then we emit metrics. We had a prototype of this at KubeCon in wherever it was in November, I forget.
Salt Lake City. No, in Atlanta, right?
Yes, that's right. That's right. I've been to a few too many of those, but where we showed emitting metrics around individual tool calls and things like that, and even just the ability to surface the fact that you have MCP traffic in here is interesting, because sometimes you might not even know you have an MCP server running in your environment or a client in your environment. So, all sorts of interesting stuff just from the basics of parsing that protocol.
That's interesting. And how do you see that all evolving from microservices, service meshes, AI workloads? How do you think, also for us as an observability vendor, how do we have to evolve to work with all that different workloads and traffic, and for us it's traces and mostly, right? Caught.
I think the AI is going to take care of it, Mirko. Don't worry about it. Just you and I will get to relax. Maybe we'll learn how to paint. AI is going to take care of all that stuff.
That's a good point.
Why should we struggle with these difficult problems when the AI can? No, obviously this is a fast moving space, so like you can make any prediction you want, and I think it's very hard to be accurate, but you still have to like kind of have an idea of how it's going to work. So for me, the analogy that is in my mind is, if you look at programming today with like Claude versus programming, even 5 years ago, it's striking just how big of a leap it's taken, and how you're able to operate at such a higher level. Like, I'm writing more code now than I've written for the past 5 years, and I'm not writing a line of it. I am instructing Claude on what I want to happen, and like Claude does it. And you got to learn how to use that tool, right? It's not infallible. In some ways, it's extremely dumb, and you have to learn like where you have to be, very opinionated with it, and where you can kind of let it go off. But you're able to now write code by describing what you want. Okay, fascinating. Is there a similar analogy to observability? Where we're not going in there and configuring our Grafana charts and like worrying about what's the x-axis and the y-axis, or we're not setting up our rules and we're like, okay, P95 less than 8 milliseconds, that's green, but greater than 8 milliseconds should be yellow. Like, we should be able to operate at a similar level where we're describing to the system, hey, if something looks weird, and here's like how I think it's going to look, just let me know. And it feels like that has to be the natural evolution. No one wants to spend their time. Well, I don't know if no one wants to. Probably people want to, but no one should spend their time, tuning those little bits. We got to move to a higher level of abstraction and move on to the next thing.
I somehow agree. The one of the biggest issues was always that defining that abstraction is not easy, right? Because one of the issues in observability has always been, you have these millions of different metrics, millions of logs, millions of traces, and at least today, I cannot look at all of this, right? And especially not in real time. So you have to define an abstraction where you can actually see. And by the way, for humans, it was always somehow dashboards, right? So you can, as a human, we are really good at looking at something like a chart or a graph that could contain millions of data points, and we can see a spike, or we can even see. I was sitting in a lot of rooms when I was a developer, and you look at the chart every day, and one morning you come in and you say, "Oh, this looks weird," right? You don't even know why, but your brain tells you this is not how it looks normally, right? and we are good at it. And at the moment, at least, the LLMs are not really good at exactly that, right? So we have to find, in my point of view, some sort of abstraction which can be used by an LLM, right?
Yeah.
And then understand what weird is, right? Because that's the problem, right? What is weird?
Is that ultimately consumed by a human though? Like,
No, I think it must be it's not consumed by a human anymore, right? It's consumed by an LLM
Yeah.
first,
yeah. Okay.
and then it will tell the human that it found something, right? But I think we need to define that, I don't know, KPI or whatever we trigger
Yeah.
in a way that the LLM can interpret it, right? Which is very different from what we can interpret as a human, I think.
Wow. So
Yeah,
now we're trying to make life easier for the LLM.
exactly. I mean, I had discussions here on the podcast where we're discussing, should we change also the way we send telemetry, right? Because telemetry today is also sent for a human to look at it, to read it.
Yeah.
Maybe at some point we will send telemetry that looks very different because we make it optimized for an LLM.
Yeah. So instead of like UX, we're now talking about AX, right? What's the AI experience? Not the user experience. We want the AI to have a good experience.
It's possible, right? That we will optimize
Yeah.
for agents.
Yeah.
Yeah,
No,
absolutely.
it makes a ton of sense. I mean, if you think about it, yeah, we're emitting log lines that are, structured in a way to make it easy for humans to recognize. And then we have all these LLMs that have been trained to like interpret language, but like really translating that data into like that text form and then untranslating it into like LLM, weight activations or whatever the hell's going on in the GPU. Yeah, it's pretty silly. It seems like there should be a shortcut there.
Yeah, also maybe we add data to a log so that the LLM can make more sense out of it, right? And normally we humans are not good at looking at, I don't know, 1,000 tags at a log because we just cannot digest it, where an LLM it's pretty easy to digest 1,000 tags, right? So that could be something we have to do, or provide more context, right? That we create in our brain, but the LLM doesn't have for that log, right? Because we know it's from that server or that Kubernetes, and you have all that information too, right? You know exactly where a call is coming from, so you could add that annotations for the
Yeah,
LLM,
yeah,
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 so
yeah.
that you can create context, right? Because that's one of the biggest issues, I think, for these AI SRE tools today, is how do you create the right context so that you can interpret where's that log from, which metric can I correlate from that pod or cluster or whatever, right? Because if you don't have that context, you can't really do that.
Right. Yeah. Well, so maybe the service mesh is a source of some of that context. It's certainly, it's a source of the traffic relationships between the services. This service talks to that service, and here's like the nature of that communication. And this service talks to that service.
Exactly.
So that's it's a starting point. And I think part of that, is possible only because of the service mesh introducing its own layer of abstraction, where we're going to emit metrics not based on IP addresses and whatever, which are mutable in Kubernetes anyways, but based on service identity. So if it's A talking to B, well, we can tell you A and B instead of having to go, kind of devolve to IP addresses.
Oh, that's interesting. Are you kind of fingerprinting services, or how do you
Yeah.
create that ID?
Yeah. So what we do is, this is kind of like the core of mutual TLS, is you have to have some identity on either side. And so we bootstrap that identity from your service account token. There's other things you can do, like, if you're running Linkerd, so we have this mesh expansion feature where you can run the proxy on a VM kind of outside of a Kubernetes cluster. In that case, you don't have a service account token, so we'll use something like Spiffy, which is like this enterprise, identity generation, blah, blah, blah. But one way or another, like, we need some identity for the workload, and Kubernetes will take your service account token, and then we just wrap that up in your TLS certificate, which we'll issue for you. So when a call comes in, I know I'm service foo and you're service bar, and I know that, and I can prove that cryptographically. I can write that to the logs. I can deny traffic. I can say, oh, you're only allowed to talk to certain routes and not other ones. I can say, oh, you're an MCP, I know this is MCP traffic, so you're allowed to call this tool, but not that one over there. All those things are doable, but they all require having some identity on the other side that you can trust, right? So if I'm just looking at your IP address, then it's not really trustable. Those are easy to spoof. Well, they change anyways over time, but your kind of cryptographic identity, okay, well now that's something that I can really do policy on top.
Yeah, I mean, this change is the biggest problem, right? Also for us to re-identify a service, right? Because an
Yeah.
IP address will change and
Mhm.
and you cannot rely on it. So
Yeah.
having that identity is already a good abstraction. Yes,
Yeah.
absolutely.
Yeah. And I
Yeah.
remember that was a big problem, back in the Twitter days. If you were operating, you might be operating some service like the photo service, and then suddenly your internal traffic would spike by 10x. And you'd be like, where is this coming from? Well, I don't know. We can go find some IP addresses and they correspond to something in Mesos. But really what we wanted was to know, like, what's the name of the service? Who did that? So I can go talk to that team and be like, hey, did you know you're suddenly doing this thing? So client identity is key to so much, both in observability and in security.
Yeah, absolutely. Absolutely. That was super interesting for me to talk to you and understand more about service meshes and the relationship to observability. It's a very interesting space, and I can see that this is also changing for you a lot with this MCP and agentic traffic. Yeah.
Yeah, it's a fast moving space, but that's part of what's exciting about it.
Yeah. Thanks for coming on this podcast.
Yeah, thanks for having me. I had a great conversation. Thank you so much, Mirko.
Thanks for listening. I'm always sharing new insights and insider knowledge about observability on LinkedIn. You can follow me there for more. The podcast is produced by DevZero. We make observability easy for every developer.